this video we would do some examples on the things we have learned. Okay, so what I would recommend is you just pause the video when I announce the problem statement, and then do it by yourself, and then you can play it again and check the solution. Okay, so we would continue with our first example to um, count number of digits in an integer. Okay, so like there is some integer or a number given. Okay, suppose 1 2 3 4. So I have to count the number of digits in the number. So let's code for that. So I'll write the main function, and inside the main function there is a number, uh, and suppose that number is 1 2 3 4 5 6 7. Okay, now I'll declare a count. And in at every loop I'll increase the count by 1. Okay, so count is equals to 0 at the start. So what is the basic logic behind this? Like, we have to use loop and iterate the loop until some condition or something is evaluated to false. Okay, so I can use while loop. I can use any loop in this, but I'll use while loop. Okay, so and counting of digit. Okay, so at every tens place there is a new digit, every tens hundred place. So when I divide the number by 10, so the number of digits get reduced by 1. Okay, and um, when I divided by 10, there is no decimal anything taking place, because the number is integer. Okay, so when I divide 1 2 3 4 5 6 7 by 10, the answer is 1 2 3 4 5 6, not 1 2 3 4 5 6.57. Okay, so I'll use while loop, and the condition would be number not equal to 0. Okay, so while the number is not equals to 0, I'll divide the number by 10 and store it in number or num, and I'll increase the count. Okay, so what happens here is, after first iteration, num will be divided by 10 and its value will be 1 2 3 4 5 6. Then the count is incremented to 1. After the second iteration, the value num would be 1 2 3 4 5, and that is incremented to 2. After the third iteration, the number would be incremented to 1 2 3 4, and so on. So after the seventh iteration, the number would be increment. After the sixth iteration, number would be incremented to 1. Number would be 1, and the count is incremented to 6. And again, at the seventh iteration, the count is incremented to 7, and the num becomes 0. So again, when then the test expression is evaluated to false and the loop terminates. Okay, so I can write a print statement here. Mm, number of digits in num is, or I can say in num is count. Okay, so when I run this program, the answer, or the output should be 7. So let's see. Okay, So the number of digits in 0. Now why it is showing 0 here? Because we have done all the calculation and we have divided num by 10 and so on, and then num becomes 0. So what I'll do is I'll change here. I'll take a value number that would be equal to 1 2 3 4 5 6 7. It is the input, and then I'll introduce a variable num that would be equal to our number. Okay, and now here I can do number. Now when I run this program, I can see that it works on pretty well. The number of digits in 1 2 3 4 5 6 7 is 7. Okay, moving forward, uh, in the next example, we would write a Kotlin program to reverse a number. Okay, so what I should do for reversing a number? For reversing a number, I can do is what I can do is I can uh, introduce a lot of variables. Okay, so it is not a right choice because we don't know the uh, count the number of digits in the integer. Okay, so what would we do is we would first when we divide the number by 10. Okay, so the remainder we get is like when we divide 1 2 3 4 5 6 7 by 10, so the remainder is 7 here. Okay, when we divide it by 10, so like this would be the first digit of the reverse number. So let's go ahead and think as we code. So there is a variable number, this which is the output, which is the input. Let's say it's 1 2 3 4. Okay, so then I'll introduce a variable num which is equals to the number. Now I'll increase a variable reversed, and for now it is 0. Okay, so I'll introduce a while loop while num is not equal to 0. Okay, now I'll introduce a variable digit. Okay, and this digit is equals to num this digit is equals to the remainder when num is divided by 10. Okay, now this is the last digit or the 4 in the first iteration. So the reversed number would be equals to the old reverse number, which is 0 for now. Okay, into 10 and plus the digit. So now when we come to the second iteration, so the old reverse number is multiplied to 10 and shifted one bit left side, and then the digit is added. Okay, so from this the number could be reversed, and at the end I divide the number by 10. Okay, so it helps in like when in the next iteration. Okay, so I'll just explain this code once again. In this program, while loop is used to reverse a number as given as I'll say uh, first the remainder of num divided by 10 is stored in the variable digit. Now digit contains the last digit of num, that is 4. Then the digit is added to the variable reversed after multiplying it by 10. So multiplication by 10 adds a new place in the reverse number. 1th place multiplied by 10 gives you 10th place. Okay, so 10th place gives you 100 and so on. So in this case reversed contains 0 into 10 plus 4 equals to 4. So num is then divided by 10, so that now it contains the first 3 digit, that is 1 2 3. After second iteration, digit equals to 3, reverse equals to 4 into 10 plus 3, 43, and num is equals to 12. After third iteration, the digit equals to 2. Okay, and reverse equals to 43 into 10 plus 2, that is 432, and num is equals to 1. And after the fourth iteration, the digit equals to 1, reverse equals to 4 and 432 into 10 plus 1, that is 4321, and num is equals to 0. Now as num equals to 0, the test expression fails and while loop exits, and reverse already contains the reverse number, that is 4231. Okay, so before running this program, I'll write a print statement. Print the reversed number is okay. Now when I run this program, I can see that the reverse number is 4231. Okay, so this is all for this video. Stay connected.